Morning everybody. Today's MCA review is going to be on order of operations in rational and irrational numbers. So, first of all, we're going to start with order of operations. Now, when we do order of operations, if you remember, we have to remember the word PEMDAS. So what PEMDAS is just an acronym for our order of operations. The P stands for parentheses, the E stands for exponents, the M stands for multiply, D divide, the A is addition, and the S is subtraction. The M and the D are on the same level, or the same plane, just as the A and the S are. So if you see an M or a D come before the M, do that first. They're the same thing. They're just written in PEMDAS just like that, even though they mean the same thing. So whichever comes first, that's the one you do. So the first thing we got to do is look at our parentheses. So if there's any parentheses in this problem, that's what we got to do first. We have parentheses here, but inside is just one number, so it's just telling us -3 is separate. We do have parentheses here, so 6 minus 10. We need to do 6 minus 10. So what we get then is -4. So we have -3 squared minus 7 plus -4 squared. So we did our P. Now our E, our exponents, we need to do the exponents, so -3 squared. -3 times -3 is 9. So we have 9 minus 7 plus -4 times -4 is 16. So now we just have 9 minus 7 plus 16. So the A and the S are on the same level. We just got to do whichever one we see first. So 9 minus 7 is 2 plus 16 gives us 18. So the answer to our problem then is 18. Let's try another one. Again, we have PEMDAS. If it helps you to write this up on every one of your problems, do it. First thing we're looking for is parentheses. We have parentheses, but it's just telling us to do this number in parentheses. Then we're looking for exponents. So we do have an exponent. So we have 14 plus 2 squared. 2 squared is, or -2 squared. -2 times -2 is 4 over 8 minus 6. Now this is where it gets a little bit different. Before we divide, we need to get one number on the top and the bottom. So we need to have 14 plus 4, which is 18, and 8 minus 6, which is 2. Now we can divide. 18 divided by 2 is 9. So our answer is 9. Our next problem, it says evaluate the expression when x equals 4, y equals 12, and z equals 9. So we are going to put these numbers in for their letters. So when x equals 4, instead of x squared, we are going to have 4 squared minus whatever our y is. Our y was 12 times our z was 9 plus 4. So what we got to do is do our parentheses, or our PEMDAS first, so our parentheses first. We're going to look inside of our first parentheses, we have an exponent that we need to do before we do anything else. So 4 times 4 is 16 minus 12. That gives us 4. So inside this parenthesis we have 4. Here we have 9 plus 4. Well, 9 plus 4 is 13. So now we're done with our parentheses. We only have multiplication left. So 4 times 13. Well, 4 times 13 is 52. So our answer is 52. Next one, we're going to evaluate the expression when x equals 4, y equals 12, and z equals 9 again. So we have 42 plus our z is 9, minus our y is 12, minus 20. Well, we're looking for our parentheses. We have parentheses, so we have to do those first. So we're going to have 42 plus 9 minus 12, which is negative 3, minus 20. Now we just got to go from left to right. So 42 plus negative 3, that is 39. And 39 minus 20 gives us 19. So our answer is 19. So that's order of operations. Now we are going to go on to rational and irrational numbers. So when we have rational and irrational numbers, first we got to look at our real numbers. Our real numbers are all the numbers that we deal with until calculus. So any number that you have until you get to calculus is going to be real. The rational numbers are integers, so every number. Whole numbers, so anything higher than or 0 and up. And every fraction or decimal. So negative 1/4, or 1/2, or 0.5, or negative 2.34, or 2 2/3. All of those are rational numbers. Irrational numbers are numbers that do not end or repeat, or they're non-perfect squares. So 3 is a non-perfect square, so that would be irrational. 8 is a non-perfect square. 35 is a non-perfect square. Those would all be irrational because they do not end if you would divide those. So if I would divide, or not divide, find the square root, if I found the square root of 3, that gives me 1.73205 ... goes on and on forever. That would be an irrational number. So again, rational numbers can be written as a ratio of two integers. So a ratio is something x over y. So two integers, numbers, any number, negative or positive. Here, our ratio could just be 11 over 15. That would give us our fraction, our ratio. Here we have 3.5. So that half could give us or make a 2 down there. So 3.5 then would be 7 over 2. That's our ratio, 7 over 2. Here, the square root of 49 is 7. And a whole number written as a ratio is 7 over 1. So we need to figure out if this number is rational, irrational, both rational or irrational, or neither rational or irrational. So if these numbers are any of those. Well, first of all, we have a non-perfect square in here. Anything that's a non-perfect square is irrational. So we can say that this is irrational. Here we have a fraction. If we made this into a mixed number, it would be 49 over 3. Or negative 49 over 3. This can be written as a ratio, so this is rational. This number looks like it ends right there. So it ends. If it ends, it's rational. If it doesn't end, it would be irrational. And pi. This is the symbol pi. Pi is always going to be irrational. Pi never ends, so it's irrational. Lastly, we need to see if the number set contains rational, irrational, both rational and irrational, or neither rational or irrational. Well, we know that it has rational numbers, it has a perfect square, and it has a number that ends. So this set is only rational. Here we have a whole number, we have a fraction, we have a perfect square, and we have a number that ends. So this one is also rational. So both of these sets contain only rational numbers. Oh, hold on 1 second, I made one mistake. The square root of 2. The square root of 2 is actually not a perfect square. Sorry, that's my fault. So 2 is not a perfect square. So this one would be irrational. This one would have both rational and irrational. Sorry guys, that's my fault. So both rational and irrational, and the other one is just rational.